So we spent a lot of time on the internals of JavaScript, but this does matter. If you're working with a language, you need to understand at least a bit how it works under the hood so that you can optimize your code for it and you're not surprised by strange behaviors. The last important concept I want to have a look at here is the concept of garbage collection. Now, let's ignore the stack for that. The stack is short-living memory, and as you saw, the stack is cleared automatically because items, function calls, execution contexts are popped off when they're done. But what about the heap, that long-living memory? How is this memory managed? It's important that it's managed because otherwise it might overflow at some time. The operating system of your computer, of your machine, of course only allocates a certain amount of memory to Chrome, and if that would be exceeded, it would simply kill Chrome at some point of time. Now actually, that will never happen because Chrome also has internal memory management, and it will simply kill your website before it occupies too much memory. So you want to avoid that. And the good thing is, you don't really need to actively manage memory unless you're building super complex, three-dimensional, calculation-intensive applications, which you might want to build in totally different ways to begin with. So let's ignore that. But still, there are some things which you should keep in mind and which you should understand. How does Chrome manage this memory? Well, there is a thing which is called the garbage collector. Every JavaScript engine has one. So here, let's say we're talking about V8's garbage collector, which is the engine, the JavaScript engine Chrome ships with. But of course, Firefox and so on, the engines built into these browsers also have a garbage collector. Now, what does the garbage collector do? And just a quick note, in case you have a night where you really can't sleep, attached you find a detailed document of how the V8 garbage collector works, in case you're interested. And you can therefore definitely check out this document if you want to learn all the nitty-gritty details. I'll not dive that much into detail here, because again, that really is beyond the scope of this course. We're not trying to build our own browser, we're just trying to understand what the browser, what the JavaScript engine that is part of the browser does for us. So what does this garbage collector do? In the end, it periodically checks the heap memory for unused objects. And unused objects are objects without references. Now remember, references are these things, the addresses in the end, which are stored in variables. And therefore the garbage collector will go ahead and basically remove, clear all unused objects from the memory, from the heap memory. All the objects where it sees that you certainly won't work with them anymore in your code. Now that's great, let me show you an example. Still, this is this mini app or this mini demo which we started working on a few lectures ago. And in there, let's add a new variable. Let's say a variable person. Now we don't need that for this application or for this demo here, of course, but let's say in some app we had this person variable. It holds an object with the name of Max, let's say, and therefore, since this is an object, this is of course a reference value, and this is stored on the heap. Now, as long as we have this variable, the person variable, holding the address of this object, JavaScript sees that we hold a reference to this object, that we're interested in its address. And as long as that is the case, JavaScript will not clear that object from memory. Instead, what JavaScript is looking for, whether there are any variables or any places in your code where you're referencing an object like this one. So when would garbage collection kick in? Well, in this example here, as soon as we, for example, set person equal to null. What we do here is we assign a new value to this variable, and the consequence of that is that this object here is no longer referenced by anything in this script. There is no place in the script where we would be interested in its address. This address is not stored in this variable or anywhere else. And JavaScript detects this and sees that this address, this pointer to this object, is not used anywhere, that you have no variable or no other place in your code where you're referencing this object, and it can now clean this up. Now actually, the way modern browsers, modern JavaScript engines work is such that even objects, arrays, which are also objects, and so on, which are stored in variables which you created with let or const, can be cleaned up by modern browsers with modern JavaScript engines, therefore, if you're not using these variables anymore in any place of your script. So you don't have to set a variable to null to let the browser clean this up. If you're not using the variable anymore, that will also be picked up by garbage collectors. So these are just different examples of when the garbage collector kicks in and will try to free up memory. Now, it will not instantly do so once you set person equal to null. The JavaScript garbage collector can't be triggered by you. You can't force JavaScript to go ahead and garbage collect. Instead, it will run its algorithm, its logic for that. And by the way, attached you find a resource which allows you to dive deeper into the internals if you're interested. It will do that on its own schedule, following its own logic, but it will eventually pick this up and clear this from memory. Now that's a good mechanism, and as I mentioned, you generally don't have to do anything for that to happen. You don't have to tell the browser that it should go ahead and do garbage collection, for example. It will try to do that in a smart way without interrupting your web page or without slowing it down, without being visible to your users. Now, you should still beware of memory leaks. That is when you actually write code where you have a certain object which you don't work with anymore, but you still have a reference to it. So you still have some variable or some place in your code where you still hold a reference to that object. And even though you're not interested in it anymore, it's still there and there still is a reference to it, and therefore it can't be garbage collected. Because even though you don't want it anymore, you wrote code that doesn't make it clear that you don't want it anymore. So you basically have a bug in your code. And in this little application, there actually is an example for this. Let me show you how we could actually introduce a little bug here in this application. We have two event listeners here, right? This event listener here at the bottom executes or is set up when this script executes. This other event listener here is only set up when we, trigger this first event listener. Because this first event listener is attached to this add a listener button. And when we then tap this button, we trigger this add listener function, which sets up the event listener on the other button, which is that click me button. So the click me button only gets an event listener once we clicked the other button. Now, when we then click that click me button, we in the end execute print message. Now, if we have a look at what that yields, here, if we open that in the browser, we can see that if I enter something here and I hit click me, nothing happens, nothing appears here in the console. If I click add a listener though, and then I click me, you see test getting output there. One test for every click. Now if I change that text, we see that text being output. Now if I click add a listener multiple times here, I still only see one output per click on click me. So it's not the case that this print me message would run more often, because you could think we're adding more and more event listeners to this button. So with every click on that add a listener button, we add a new listener to the click me button, and therefore we might see this function being executed more often for every click, but that's not what's happening. And the reason for that is that JavaScript here is really smart, or the browser and JavaScript together. And if you add an event listener to a button or to any element with an event to which you listen and a function which you already used before, JavaScript will replace that old listener with the new one and not add a brand new one. And that's a good behavior, because otherwise you could easily end up with hundreds of event listeners on the same object, and that would probably lead to a behavior in your app which you don't want and introduce memory leaks, because you're populating your memory with all these functions. And functions in the end also are just kind of objects, and they're therefore also stored in the heap in memory, and they, clutter up that memory over time. So it's good that the browser doesn't allow that. Now we can actually trick the browser if we copy that function and replace print message here with that function and remove that name. Now, we haven't seen that before. That's a so-called anonymous function. We'll dive deeper into that in the functions module. And whilst this might look strange, what this does is it creates a function here in place. It just doesn't assign a name to it, but it's still getting stored in memory. And the pointer to that function, the address of the function, is simply then passed in as a second argument to add event listener. So this function is created on the fly, so to say. It's not getting executed immediately or anything like that. It behaves just as when we pointed at print message. But the difference here, and that's a crucial difference, is that this function doesn't have a name, and it is indeed created as a brand new object whenever this add listener function runs, because this function is created here on the fly. Previously, this print message function here was only created once when this entire script ran for the first time. Then this code never runs again, and therefore only one function object is created. Here we create a new one whenever add listener runs. Well, and the behavior we see therefore is that if I enter something here and I add a listener and I click me, we got the same as before. But if I click add a listener multiple times here, we see more and more outputs printed for this test thing here for click me, right? So we see more and more outputs being printed, one for every time I clicked the add a listener to the other button. And that simply is the case because a new function is now created for every execution of add listener. This is dangerous, or a potential problem at least, because that can lead to memory leaks where you have dozens or hundreds of function objects in your memory and JavaScript is not able to clean them up because every execution of add listener creates a brand new function. To JavaScript, this is a brand new object, not the same as before, and therefore it thinks, okay, you want to add a new click listener with a new function than you did before. It doesn't see that the function does the same thing as the old function. To JavaScript, since we create a new function, it is a new function. So that's something you should be careful about. Now, this is a very rare and constructed scenario here, of course, and we'll dive deeper into anonymous functions, into event listeners, and also into performance management later in this course, but it is something which I want to highlight here, so that you understand the importance of the job of the garbage collector, that it does a lot for you, but that it's also not some magical tool that can rule out any errors you introduce. Now again, we'll dive deeper into this and also how you can find and fix memory leaks later in the more advanced parts of the course. So you don't need to worry about this right now. In most cases, you don't introduce such leaks because it's not that easy, thankfully, to add them. The garbage collector is really smart. Just still important to mention it right here.